All right, today we're going to look at combining like terms. All right, like terms are terms that are exactly alike. So each one of these is a term. X squared is a term, 3x is a term, 4 is a term, this x squared is a term, 4x is a term, and 3 is a term. All right, so when we combine like terms, it's like combining circles and squares and triangles. So you put things that look alike together. Now, x squared is its own term, and the coefficient in front of that x squared is 1. So if you can see it, you have at least 1. If you have more than 1, you will have a coefficient that is larger, like on 3x. Okay? So when we're doing combining like terms, there's a couple of ways you can go about this. You can leave it all in a string like this, and you can underline the things that are alike. So you have 1x squared plus x squared. The operation in front of the term belongs to that term because we read left to right. So it says 1x squared plus x squared. Now, this coefficient is 1 also because there's no number in front of us in front of it to see. So we have 1x squared plus 1x squared, so that gives us 2x squared. So when I'm done with them, I cross them out. I put a light line through them so I know that I've taken care of it already. All right, now we'll work on the x's. So we have a plus 3x here, so that's a positive 3x. And then we have a plus 4x here. So in that case, what you do is you take 3x's plus 4x's and you get 7x's, and they're both positive, so it's plus 7x. And then lastly, we look at the numerical terms. Positive 4x plus 3, and so positive 4 plus 3 is 7. So it's positive 7. So it's for us, when we put it in the expression, it becomes plus 7. So your final answer is 2x squared plus 7x plus 7. Now, an alternate way you could look at this is by taking each of the terms. This is an alternate. That might work for some people, because having it in a string like this can get confusing. So I have x squares, I have x's, and I have numbers. So I put a little, kind of like a chart. I have x squares, x's, and then just plain old numbers. So those are my types of terms. So when I look at my x squares, I have a 1x squared. And then I plus a 1x squared. And so that's going to give me 2x squared. When I look at my x's, I had a positive 3x, so that's just 3x. And I had a plus 4x, which gives me a positive 7x. And I want that positive in front of the 7x so that I can put it into an expression. And then the numbers alone, I have a positive 4, so it's just 4, plus 3, which is just plus 3, and that equals positive 7, and I want the positive on that also, so that when I write my final answer, I'll do that over here, I will read just the end results of those categories that I put them in. So I'll have 2x squared plus 7x plus 7. And it's the same thing you got if you did it by underlining, okay? So you have a couple of ways to do it. Underline like terms or categorize like terms. Just like you would do circles, squares, and triangles, we do x squares, x's, and numbers. And then we take the end result and write it out as an expression, and that is your final answer, okay? So let's try another one. We have 3x squared minus 4x plus 2 minus x squared minus 2x minus 1. So in this case, our terms are x squared, x's, and numbers. All right, so we'll take 3x squared, but it's minus x squared, and there's a 1 in front of this x squared. So if you're going to put it into categories, the x squares are 3x squared minus 1x squared, which gives us 3 minus 1. You always subtract the coefficients, and that's going to give us 2x squared. That's the final result for the x squared term. Now we have a negative 4x because we don't look at it as a minus. We cover that up because we're done with it. All right, we crossed it out. And we have a negative 4x. So for our x term, we have a negative 4x. That's what it looks like for us. So the sign in front belongs to the term. And we read across and we get a minus 2x. Minus 2x equals. So we have a negative 4 minus 2. So the way I look at this is I have 4 negatives and I have 2 more negatives. So I have 6 negatives. And so it looks to us like a negative 6x. All right. And then lastly, we have the number terms, positive 2 and minus 1. So these are the number terms. So we have 2, which is positive, minus 1, which equals to positive 1. Okay, so now we're in a good position to take all of our final results here and write them as 2x squared minus 6x plus 1. And that's our final answer for combining like terms. All right, and one more. Not all of your terms are going to have powers that are highest or 2. They could be higher than that. So you don't want to be freaked out by it because it's easy enough to do by combining like terms. So we have a 4x cubed plus a 2x squared plus a 3x cubed minus a 7x squared plus 8. So you're saying, all right, well, I got x cubed, x squared. They sound different, so they are different. So this term is an x cubed term. And we're going to look through and find another x cubed term, and we have it here. So we have a 4x cubed plus a 3x cubed, and that results in 4 plus 3, which is 7x cubed. All right, next we're going to look at the next term we have in line, which is the negative 2x squared. Okay, we crossed those x, we're done. So negative 2x squared, that's what that looks like to us because the sign belongs to the term, and if this is not there, we would read it as a negative. So negative 2x squared, and then we're looking across and we have a minus 7x squared. So I have 2 negatives and 7 more negatives, so I have 9 negatives, so negative 9x squared. And lastly, we have, so we're done with that, we're done with that. Lastly, we have numbers, but there's no more numbers to add to it. So this 8 is just by itself. So the number term is just positive 8, and we want the operation there and as a sign, because if not, we won't know what kind of 8 it is when we write our final answer. So our final answer is going to be all of these final results in the categorizing we do, or the underlining we do, depending on which method you decide to take. And it's 7x cubed minus 9x squared and plus 8. And that is our final answer for combining like terms.